My name is Cheng, and this is actually my first time presenting at a conference. Thank you, but what I'm trying to say is I'd actually appreciate it if everyone kept their expectations low. Like really low. Like just take that bar and lower it to the ground if you can. Although we are in Denver, which means the bar would still be a mile high, even on the ground. So great. But actually, I'm really excited to talk about Model View Presenter, the life-changing magic of tidying up your presentation layer. If you didn't know, the title is a reference to a instructional manual that is on scientifically systematizing residential area assets. I'm just kidding. It's a book about how to clean your home. It's just fun to make everything sound technical. So a little bit about me. When I'm not nerding out on books about cleaning, I am a mobile developer at A6 Digital in Boston, where I work on the Runkeeper app on Android and iOS. I didn't start out in computer science, though. In school, I actually studied chemical engineering, and I went to work for Loctite after. Loctite is a glue company, so I was a glue engineer. I'm not kidding. Yeah, if you have any questions about glue, feel free to reach out. I'm happy to talk about all things glue related, because otherwise it's a lot of extremely specialized knowledge in my head that I have absolutely no use for anymore.
Is that why you didn't stick with it?
Like I said, glue engineering is fun, but I didn't stick with it. I eventually went back to school for computer science, and I've been working at A6 Digital ever since, specifically on the Runkeeper app. Oh, geez, yeah, that's my chemical engineering days, and that's my glue engineering days. So Runkeeper is a fitness app that helps users track their running and improve their fitness. So show of hands, how many runners are out here today? Okay, I see a few, all right. I don't know if maybe it's the lack of oxygen in Denver makes it a little hard to run, but yeah, Boston is a huge running city. This is a photo of me and my coworkers going on our weekly A6 fun run in Boston. My coworkers may look young, but Runkeeper the app is actually pretty old. Runkeeper launched 10 years ago, back in 2008, when it was one of the first apps in the App Store. When I started at the company a couple years ago, I didn't know I would be working in literally one of the oldest code bases in the mobile app space. Over years and years of iteration and adding new features, you can certainly imagine how messy the code could get. Perhaps this is a familiar story to some of you and your apps. If you just sort of use the Android framework as given and don't give more careful thought to the design of your Android app, you could find yourself buried under a mess of code in your activities. And that's what happened to us. Our activities grew larger and larger, unit testing became impossible, and our code grew increasingly difficult to maintain as new features were added. We knew we couldn't continue down this path. Just like Marie Kondo's best-selling book on the life-changing magic of tidying up your home, we sought to find a life-changing design pattern that would help us tidy up our code and make our app unit testable. We decided to adopt the Model View Presenter pattern, and that is what my introductory talk is on today. We'll go over what problems MVP can help you solve in your app, namely separation of concerns and unit testing. We'll talk about what MVP looks like conceptually, the steps to refactor an activity to MVP, including some examples of the unit tests, and then quickly discuss some pros and cons with the pattern. The thing is, MVP is just one of many design patterns out there. And even for MVP, there is no one right way to implement MVP. Today I'm going to provide a guide on how one particular app did it, Runkeeper, on Android, which may or may not work for your project. But hopefully you'll still take something away from this guide. So let's get started. Like I said, the first problem that we at Runkeeper wanted to solve was our huge legacy activities. As the Android Developer Guide states, it is a common mistake to write all your code in an activity or fragment. Any code that does not handle a UI or operating system interaction should not be in these classes. Keeping them as lean as possible will allow you to avoid many lifecycle related problems. I checked with some folks who've been working with Android since like Android 2.0. They said this advice was definitely not in the Android Developer's Guide back then. I think back then it was just sort of do whatever works. So I don't know when this advice came up, but it's here now. And yeah, maybe when we first created our app 10 years ago, the scope of the app was small enough to get away with putting all our code in our activities. But 10 years of expansion and development later, it certainly was not. So that was problem number one for us. Problem number two was unit testing. Because all our logic got put into activities, it made unit testing virtually impossible. Unit testing is important to us as developers. It's much faster to be able to run a unit test on the local JVM than it is to run UI or instrumented tests. They don't involve outside code testing tools like Roboelectric or Espresso. And the idea behind unit tests is that if they pass for individual units of code that is behind the scenes, it gives us good confidence that the user-facing UI logic, which is built on the units of those codes, also works as expected. However, unit testing in Android is going to be really hard if all your code you're trying to test is in an activity. And that is because the activity is bound by the Android lifecycle with lots of Android components throughout. And testing those would require Roboelectric, which, like I said, is not ideal because it's much slower to run than unit tests. So for a normal unit test, all you do is you just create an instance of that class. So for example, dateutil in this case, through its constructor. And then let's say we wanted to test this method getPreviousCalendarDay. So for example, we could pass in Monday and check that it returns Sunday. The unit test would look like this. You create an instance of that class, you call the method passing in the value for Monday, and then assert that the return value is Sunday. Simple. To test an Android activity, you can't do what you'd normally do when writing unit tests. Because activities are bound by the Android lifecycle, you don't have constructors. You have lifecycle methods like onCreate and onResume and such, which get triggered through the OS when the user pulls up the screen. You can't really call these methods yourself, and you can't really create an instance of an activity like you can with a regular class. So theoretically, you'd have to build up the whole application and start the activity just to test one small part of it. Your other terrible option would be to have all your methods that you want to test be static, because then you can just call that method directly and test that it does what you want it to do. But obviously that is awful object-oriented programming, and certainly there must be a better way. So let's see how we solve these two problems at Runkeeper. One of the areas of our app that definitely needed a little tidying up was the trip list activity. As you can see, it's a scrollable list view that shows a history of all the past trips a user has tracked with our app. A trip being defined as a single workout they ran. So you can see some of my past trips here, some really miserable runs down the Florida coast, and then also my daily commute trip into work. The trouble with this trip list activity was that there was a lot of code in this activity. Rather than separating into components, each responsible for doing their own thing, all our logic was put into one place. Okay, brace yourself. The code for this activity was massive. Just look at all the things we were trying to do in this one activity. We had lifecycle methods, networking methods, database methods, view methods, broadcast methods. Yeah, it was a pretty obvious violation of the separation of concerns. So rather than have the lifecycle methods, presentation logic, views, and data all crammed into the activity/fragment, let's start moving things out of the activity/fragment. We can certainly move the data models out. Those don't belong in the activity. We'll call that the model class. Next, let's move the Android view objects like recycler view, progress bar, etc. Out into the view class. All the view logic that dealt with the views would also go in this class. For example, the view would be in charge of things like setting up the recycler view, attaching the adapter, and other view logic such as hiding or showing views, depending on if the user was like a new user and it didn't have any past trips to display yet. Finally, let's move the presentation logic out into the presenter class, which is just a regular plain old Java object, a POJO. Anything that's not a model and is not Android-y goes in here. So as you can imagine, it's the bulk of the code. And then that essentially is how you get model view presenter. So then what's left in the activity/fragment? Just the lifecycle methods. This is how we organized our classes at Runkeeper, and it's one of the many variations of MVP that you'll see. Another common variation leaves the views inside the activity so that the activity is responsible for both the lifecycle methods and the view logic. But at Runkeeper, we chose to have this additional layer of separation because we thought the activity was already doing enough as is handling the lifecycle methods. Also, I got tired of calling the last component the activity/fragment over and over, so I'm just gonna rename that to lifecycle. Sorry if that's confusing. I'll tell you, naming things is super hard. Great, so here's what our model view presenter looks like at this point. We have the model, presenter, and view being just POJOs, while the lifecycle class extends the either activity or fragment. As a result, this lifecycle class will be responsible for handling navigation because it's the only one that knows how to start a new activity. And it'll also be responsible for passing on operating system interactions and lifecycle methods to the presenter. Just so we're clear, the model and the presenter should not contain anything Android-y. It's the view and the lifecycle that manages all the Android views and other Android classes. So the presenter should not contain any Android classes, not even the context. And you might say, well, hey, I'm gonna need the context if I'm gonna access shared preferences, right? Well, if you're clever, you won't need to use the context in the presenter because what you can do is pass in shared preferences or whatever else you need directly into the presenter. That's called dependency injection. We'll talk about that a lot more in a moment, but let's finish discussing what MVP looks like first. So just one other step we took, which is really just good practice to have in general for object-oriented programming, is to have the classes implement interfaces. The presenter had a presenter interface, the view had a view interface, and the lifecycle also had an interface. And yeah, so we had all these classes, these interfaces in a single contract class. So why do we want to have the classes interact with each other through interfaces rather than actual implementations? Well, the idea is to decouple the presenter from the actual view implementation or the actual lifecycle implementation. So like, if you were to swap out one view implementation for another view implementation, the presenter should theoretically be unaffected. If you're following solid principles, this is the D in solid, which is depend upon abstractions, not concretions. And setting up interfaces between the classes actually paid off for us at Runkeeper. So there was this one instance where we experienced the classic transaction too large exception, because we were trying to pass data that was too large to pass from one activity to another through an intent. And so our solution was to change out those activities and turn them into fragments, and then have a parent activity that would hold on to the data that the two fragments could easily access. Because this one part of our app was properly set up as MVP, all we had to do was change the old lifecycle class from an activity to a fragment. The fragment still implemented the lifecycle interface. We didn't have to change anything in the presenter's code because the presenter was expecting to interact with a lifecycle interface, and as long as this method implemented the lifecycle interface, the presenter was happy. So that's essentially what our model view presenter looked like conceptually. And sure, anyone can just draw up some diagrams and tell you that's what MVP is. But if you're like me, you want to see examples of what that actually translates to in code. Like, oops, sorry. What does it actually mean to have all that in code? So next, I will guide you through the nitty-gritty details of code to refactor an activity to MVP using our old trip list activity as an example. The first step, of course, is to split up the activity / fragment into the 4 components we just talked about, plus the interfaces that the classes will actually interact with. The second step is to connect the 4 components, with the presenter being the glue code that connects the other components together. For example, if the view needs to speak to the model, then the view asks the presenter, and the presenter then updates the model. The third step is to actually create the presenter using a factory. And then finally, after you've done that, you should be ready to write unit tests. So like we said, the first step into making your app more flexible and unit testable is to split up the activity. In the case of the trip list activity, the model, of course, was the list of trip items, and the view contained all the view and view logic, including the recycler view and the adapter. And then all the presentation logic got moved into a POJO that was the presenter. It might be worth it at this point to pause and talk a little bit more about our model class. So when I was working on refactoring our activity list into MVP, I read up on a lot of guides that defined the model in MVP to be the one that contained all the business logic. By business logic, I mean the logic that deals with the data. So storing the data, retrieving the data, updating the data. So where is that happening in this diagram? Well, the diagram that's shown here really just applies to what's presented in one specific screen, the trip list screen. The architecture of our Runkeeper app obviously has many other layers, like our REST API, database API, and at Runkeeper, we actually created manager classes to handle our business logic. We had a trip manager, a friends manager, a coaching manager, etc. A manager to handle every domain object. multiple screens across the app access these manager classes, which is why I didn't show them as part of the screen architecture. They're beyond the scope of just this one screen, if that makes sense. So what we're interested in this discussion on MVP is the thing that's shown to the right, the user-facing layer for a given screen. So what the user sees in the views, what data is backing those views, and in this case, it's the list of trips, and the presentation logic required to present that data to those views. So when I talk about presentation logic, that's what I mean. It's the logic that determines how we display data to the user. So focusing in on that layer, let's talk about all the classes that the trip list activity gets split into. And yeah, it's a lot. It's one of the drawbacks of using this pattern. In order to do MVP, your one activity class suddenly turns into 5 classes, which can be confusing at first, especially since you're interacting through interfaces. In Android Studio, Command-Alt-B or Control-Alt-B suddenly becomes your best friend for finding your way through to the actual implementations of interface methods. But once you've created those classes, actually at Runkeeper we have like a script that generates all of these classes for you every time you start writing a new activity. Once you've created these classes, then we start moving the presentation logic into the presenter and the views and the view logic into the view. So for example, in the activities on activity result, we can move a lot of the presentation logic to the presenter. When the onActivity result gets triggered in the activity calls on the presenter to perform all the actual work of determining what should happen next. So let's say the presenter determines that based on the result code and the intent, we need to perform a sync to the server. And it wants the progress bar to be displayed while that's happening. Well, displaying a progress bar, or displaying and hiding any views isn't the presenter's job, it's the view's job. And so the presenter doesn't even have access to the Android views, so it has to ask the view to do that. But continue to move things around for all the other methods. We ended up shrinking the trip list activity from 747 lines of code to just 132 lines. The number of methods also ended up shrinking from 27 to 12, and these are listed to the right. So at this point, you might be thinking, okay, so you reduced the size of the activity, but all of that code simply migrated from the activity to the presenter. So remind me again, what exactly did we accomplish? Well, remember that the presenter is just a plain old Java object. So in our unit tests, we can create an instance of our presenter Pojo, call the method we want to test on that instance, and then confirm that the result is what we want. This is the key takeaway. In other words, all that logic we moved from the activity to the presenter is now testable. It wasn't testable back when that logic was inside the activity because, like I said, we can't just create an instance of an activity like you can a Pojo and call methods on it to unit test. Okay, at this point, we have physically moved all our views and view logic into the view class. We have moved all our presentation logic into the presenter class. And if you're actually doing this on your computer right now, your IDE should be bathed in red errors because we haven't actually hooked anything up yet. We need to do step 2, which is to connect the components together to talk to each other. First, the activity needs to know about the presenter. And this one's easy. We just create the presenter, we create the presenter in the activities on create. The actual creation of the presenter needs to be done in a specific way that I'll talk about in the next step. But in terms of when the creation happens, this is when it happens. Next, the view needs to know about the presenter. So for this, we create a bind presenter method that passes in the presenter to the view. Then the presenter needs to know about everybody else. And the way it does this is to have all those classes be injected into its constructor. It sets its instance variables to those passed in, and then it calls on the view to bind presenter to itself. Notice the types on those parameters. They're, rather than expecting like an actual implementation of a model or an activity, the presenter's constructor is instead expecting interfaces from the triplets contract. So triplets contract.iView, triplets contract.iLifecycle, etc. So to recap, at this point we have split up all the activity, moved all the presentation logic to the presenter. We have set up the presenter's constructor in such a way that all the dependencies get injected into the presenter's constructor. Now we just need to actually create the presenter. So it's going back to this method in this activity where we create the presenter. So that's what we're talking about now. Step 3 is to create the presenter using a factory class. The factory is just a class that is in charge of returning a presenter. And technically, you don't need a separate class to do just this, but in keeping with the principle of separation of concerns, it didn't really make sense for us to have the activity know how to do this, and it didn't seem like it was something that any of the other existing classes should know how to do. So we created a separate class to take care of creating the presenter. By moving this class out of the activity, you have the added bonus that you can test the unit test the factory if you wanted to. You're more likely to want to unit test the factory class in situations where the factory actually returns different types of presenters, but in our case, the factory just returns one type of presenter, so. Oh, really quick side note on dependency injection. So when I talk about dependency, a dependency is any kind of object that our presenter class needs in order to do its job. For example, in the presenter code, we make a lot of calls to the trip manager throughout in various places. But when it comes to unit testing, we're not actually interested in testing the trip manager. We're interested in testing the presenter. If we wanted to unit test the trip manager, then we unit test the trip manager. But if that class is already properly unit tested, we don't need to, and we don't want to test it as part of the tests for the presenter. So in order to remove that type dependency and make them loosely coupled, we inject the dependency into the presenter's constructor, just like we did with the view, activity, and lifecycle model that got passed into the presenter. Then when it comes to unit testing, we can pass in mock objects for these dependencies. You can use a library like Dagger2 to help you with dependency injection, but I'm going to be doing it the old-fashioned way today so that it's easier to understand what is happening conceptually. But back to instantiating our factory. So this is what our factory class looks like. It's really simple. In this create method, all it does is create all the dependencies that the presenter will need, such as the trip manager, and then it returns a new presenter, passing in all those inject dependencies into the constructor of the presenter. You'll notice here that the activity passes in the context. This is great, because that's what I was talking about. Like, this is useful for creating any dependencies that require the context, such as, like we were saying, shared preferences. Or in the case of Runkeeper, all those manager classes that we use to manage our domain objects. Create those dependencies now, because remember, once you're in the presenter, you won't have access to the context. In fact, any creation using the new keyword should be done now. And then those classes should be injected into the presenter. Sorry for the wall of text, but here in this big blob of code, all I'm doing is creating all the necessary dependencies. So for example, the trip manager. And then I create a new presenter and I inject all the dependencies into the constructor, and then I return the presenter. Step 4, we are finally ready to write unit tests. Because the presenter doesn't contain Android components, all you really need in terms of tools is just plain old JUnit, and if you want to, Mockito for mocking objects. So in the unit test file, the first thing we do is mock out those dependencies. Like we said, we're not interested in testing out the behavior of all of these dependencies. We're interested in testing our presenter. So we create mock objects out of these dependencies that do what we tell them to do rather than what they would actually do. In the unit test setup, I instantiate the trip list presenter. But instead of passing in the real view, I pass in the mock view. Instead of passing in the real activity, I pass in the mock activity, and so on. Similarly, I pass in mock trip manager and mock other dependencies the presenter has. Okay, great. So now that I've got my presenter as my system under test, I am ready to write unit tests on the presenter. For example, we can write a test for deleting a trip. When the user taps on a new activity with more, when the user taps on the trip in the list, it starts a new activity with a more detailed view of the trip. So it has like more stats and actions that you can perform on this trip. They could, for example, choose to delete the activity. So let's pretend you went for a drunken run in Las Vegas, and as you know, what happens in Vegas stays in Vegas. So let's say we delete that trip. And after that trip gets deleted, we call finish on this detail view activity and go back to the trip list activity. Once we're back in the trip list screen, the onActivity result gets triggered. So let's see what that code looks like. And then the onActivity result, the activity calls the presenter to handle it. The presenter checks if the deletion has occurred and calls a method to delete that trip from the trip list. So real quickly, here's how we test this. First thing, we check how many trips are in the list before deleting. Then we set up the conditions of the test. We set the trip deleted to be true. Then in the act step, we execute the handle activity result method in the presenter, passing in trip deleted equals true. And then we, in the assert step, check that the number of trips in the list is in fact one less than was before. Let's do another example. Swipe down to refresh on the trip list. When the user swipes down to refresh the trip, we make a call to sync with the server to make sure we have all the latest trips. Let's see what the code for that looks like. So when the onFresh senses that the user has done a swipe down to refresh on the view, it notifies the presenter. The presenter then calls another method in the view, update UI for sync in progress. That sets the progress bar view to visible and the recycler view to invisible. Then in the presenter, we call the web client to do the syncing to the server. So let's write a test that just asserts that when this trigger activity push sync is called, that the progress bar does in fact get displayed. However, we only want to test that the view shows the progress bar. We don't want to test the part about the web client going off and making a web call to sync with the server. Assuming the web client class was already properly unit tested, we don't want to test that the web client dot begin sync does its job. In the test, we just want to treat the web client like a black box, and luckily we can do just that because web client was one of those dependencies we mocked and passed into the presenter when we created the presenter in the test setup. So in the test, we can set up the test to do nothing when the mock web client dot begin sync gets called. The beauty of mock objects is that you can have them do what you want them to do rather than what they would normally do, which is to go off and perform the web call. After you've set up the test, then we can call presenter.triggerActivityPushSync in the act step. Then in the assert step, we assert that this helper function we have in progress returns true. And I'm not showing the code for this in progress method, but you can just imagine that it checks that the progress bar's get visibility is view.visible. So hopefully those examples gave you a good idea on how dependency injection and mock objects help to be able to test some of the presentation logic. But remember, this is all possible because we MVPified the trip list activity by moving the presenter logic into the presenter. One of my mentors told me, if you want people to actually retain information you present in a presentation, you need to tell them 3 times. So for the 3rd time, let's recap the steps that we took to refactor the trip list activity to MVP. Step 1, split up the activity into the model, view, presenter, and lifecycle. Step 2, connect all the classes together using interfaces rather than actual implementations. Step 3, create the presenter using a factory pattern where we create all of the dependencies and then inject them into the constructor of the presenter. This allows us to later inject mock objects into our presenter to later use when we write unit tests. And step 4, write your unit tests. Some pros and cons for refactoring your code to MVP. So let's start with the cons first. As you saw, refactoring to MVP requires a lot of classes and interfaces, which can be kind of annoying. Also, depending on how your code is set up, you'll want to give some thought to what happens when the activity gets destroyed. When your activity gets destroyed, you must make sure that your presenter destroys any RxJava subscriptions or async tasks, or else that's going to cause problems when the task finishes and then the activity is no longer there. You also need to think about what happens to the presenter when the activity is destroyed. In our case, we wanted the presenter to be garbage collected when the activity got destroyed. We had to make sure that the presenter was then given a chance to be garbage collected by having it not be referenced by other classes. If you do want to have your presenter survive activity destruction, you have a couple options. You can try to save some of the state through the on-state instance state, or else use loaders, which survive configuration change. Another way to deal with these lifecycle issues is to use Android architecture components to make your presenter lifecycle aware. We haven't done this at Runkeeper yet, but it's a reasonable next step for us, and incorporating it would be very doable alongside of the existing MVP classes. And then the benefits, I think, certainly outweigh some of the inconveniences. By separating their activities into the MVP pattern, you'll be able to achieve separation of concerns. And by moving all of your presentation logic into a presenter, you'll now be able to write unit tests on previously huge and untestable activities. So that's all I got. Thanks for bearing with me through my first ever presentation. If anyone finds himself in Boston, reach out and we can go running with the A6 Run Club sometime. Thank you.